morning. So we are in the module 1 and we are going to move to the next topic, that is about the electrodes, that is reference electrodes. Under reference electrodes we will be discussing about the construction and working of a calomel electrode. In the previous class we discussed about some of the general thermodynamic functions and we discussed about the derivation of Nernst equation. Okay, coming to the reference electrodes. What are reference electrodes? The reference electrodes are the electrodes having the constant or known potential. Reference electrodes are the electrodes, they will be having a constant or known potential and they are used to calculate the electrode potential of any unknown electrodes. Fine. Reference electrodes are the electrodes, okay, with reference to which the electrode potential of any other electrodes can be calculated. There are two types of the reference electrodes. They are primary reference electrode and the secondary reference electrodes. What are primary reference electrodes? Primary reference electrodes are the electrodes having constant or known potential. Okay, for the primary reference electrode, the example is standard hydrogen electrode. Okay, previously, standard hydrogen electrode was used and you should have studied this in your few classes. Now the standard hydrogen electrode is no more used. Okay, no more primary reference electrodes are there now. We will be using only the secondary reference electrodes. That is due to the difficulties caused in a standard hydrogen electrodes. What are the difficulties caused in a SHE? That is, it is difficult to maintain the concentration at 1 atmospheric pressure and the potential will be varying with the variation of temperature, and the platinum wire gets easily poisoned due to the impurities present in the hydrogen gas. So due to these difficulties, the standard hydrogen electrode is no more used. The secondary reference electrodes came into the existence. What are the secondary reference electrodes? Secondary reference electrodes are the electrodes. They will be having a constant and reproducible potential and they are used to determine the electrode potential of any unknown electrodes. Secondary reference electrodes are having constant and reproducible potential and they are used to determine the electrode potential of any unknown electrodes. Okay, and the difficulties which were caused in the primary reference electrode is not there in the secondary reference electrodes. Okay, as the standard hydrogen electrode is difficult to construct and this will be very easy to construct and the potential will not be varying with the variation of the temperatures and it will be showing a very least errors. Okay, whatever the values we will be measuring, that is almost accurate values. Almost we will be getting a accurate 100% accurate values. So the secondary reference electrodes are used nowadays. Okay, so the secondary reference electrodes examples are calomel electrode and silver chloride electrode. For us in our syllabus we have construction and working of a calomel electrode. Okay, so coming to the construction and working of a calomel electrode. Okay, so it will be a tube like structure. Okay, let us see the diagram first. Okay, the electrode will be like this, something like this. Okay, so what and all it consists of? At the bottom of the electrode there will be a presence of a mercury and on mercury there will be a paste of mercury and mercurous chloride will be there, and on mercury and mercurous chloride paste there will be a presence of a KCl solution. Okay, KCl solution of what type? Either 0.1 normal, 1 normal or saturated solution of the KCl is used here. Okay, so to fill the KCl solution there will be a side tube, fine, and there will be a platinum wire which is inserted up to the mercury, up to the bottom, that is up to the mercury level, that serves for external electrical contacts. Okay, so let us go back. This is about the electrode diagram. Okay, so the calomel electrode consists of mercury at the bottom of the tube and the mercury is covered with a paste of mercury and mercurous chloride. Okay, the commercial name of the mercurous chloride is a calomel. So the electrode is called as a calomel electrode and the KCl solution is introduced into the tube through the side tube. A platinum wire is inserted up to the bottom of the electrode, serves for external electrical contacts. Okay, and the electrode is coupled with any other electrode by using either a salt bridge or a porous membrane, and the calomel electrode acts both as anode as well as cathode depending on the nature of the other electrode. That's why we can find out the electrode potential of any electrodes. Okay, as the electrode acts as anode as well as cathode, which depends on the nature of the other electrode. When the electrode is acting as a cathode, the cell reactions are, see what happens when it is acting as a cathode. Hg2Cl2 plus 2 electrons gives 2Hg plus 2Cl minus. Okay, when the electrode is acting as an anode, the cell reactions are 2Hg plus 2Cl minus gives Hg2Cl2 plus 2 electrons. Fine. And the overall reaction can be written as 2Hg plus 2Cl gives Hg2Cl2 plus 2 electrons. And the electrode potential of the calomel electrode is given by Nernst equation. E is equal to E naught plus 0.0591 by N into log of chloride ion concentration square. Okay, so it is clear from the above equation that the concentration of the calomel electrode depends on the, the concentration of the potential of the calomel electrode depends on the concentration of the chloride ions. The potential of the calomel electrode depends on the concentration of the chloride ions. Okay, so I told you we are using three different types of KCl solutions in the electrode. Okay, which solutions are used? 0.1 normal, 1 normal and saturated. Okay, and we should remember one more thing here. Okay, when the 0.1 N KCl is used, the electrode is called as a decinormal electrode. If 1 normal KCl is used, that is the electrode is called as normal calomel electrode. And if saturated solution of the KCl is used, the electrode will be called as a saturated calomel electrode. Okay, and I told you just now the potential will be depending on the concentration of the KCl solution used. So if we use 0.1 N KCl solution, the potential is found to be 0.33 volts, and when we use 1 normal solution of KCl, the potential is found to be 0.28 volts, and when saturated solution of the KCl is used, the potential of the electrode is found to be 0.2422 volts. Okay, so the potential depends on the concentration of the chloride from KCl solution. Clear? And coming to the advantages of the electrode, it is easy to construct and the potential does not vary with the variation of temperature. The electrode is very easy to construct, potential does not vary with the variation of temperature. Okay, so these are the advantages compared to the disadvantages of the standard hydrogen electrode. It was difficult to construct and the potential was varying there with the variation of temperature, right? Okay, here it is easy to construct and the potential does not vary with the variation of temperature. They will be having a constant and reproducible potential. Fine. And coming to the applications of this electrode, okay, where it is used, when the electrode is when the electrode is coupled with the like glass electrode, it is used in the determination of pH. And when it is combined with the platinum electrode, okay, platinum electrode, it is used in the determination of potential of the redox titrations. Okay, these are the applications. It is used in the determination of pH when combined with the glass electrode, and it is used as a used to determine the potential when it is combined with the platinum electrode. Okay, so once again the main points to remember here when it comes to the construction and working of the electrodes. Let's start with the secondary reference electrodes. You have to write the secondary reference electrodes are the electrodes, okay, will have a constant and reproducible potential. Okay, and the electrode, calomel electrode consists of mercury and mercurous chloride paste, and anthode KCl solution. KCl of either 0.1 N, 1 N or saturated KCl solution will be there. There will be a platinum wire for external electrical contacts, and there will be a side tube to fill the KCl solution, and there will also be a salt bridge or the porous membrane, okay, that is for combining with the other electrode. Fine. So that is about the structure of the electrode, and the electrode will be acting as both anode as well as a cathode depending on the nature of the other electrodes. Okay, so when it is acting as a anode, you have to show the like liberation of electrons. When it is acting as a cathode, you have to show the reaction with acceptance of electrons. And the potential of the calomel electrode is given by the Nernst equation. E is equal to E naught plus 0.0591 by N into log of chloride ion concentration square. Okay, so it is very clear from this equation that the potential of the calomel electrode depends on the concentration of the chloride ions in the KCl solution. Okay, So depending on the concentration of the KCl solution, the potential also will be varying there. Okay, and advantages of the electrode are it is easy to construct and the potential will not vary with the variation of the temperature. Okay, and coming to the applications, it is used in the determination of pH when it is combined with a glass electrode, and it is used in the determination of potential when the electrode is combined with the platinum electrode. Fine. So we'll be meeting shortly with a new topic. Thank you.